Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for maximum sum circular subarray problem. Let's look at the problem description. We are given a circular integer array nums of length n and we have to return the maximum possible sum of a non-empty subarray of nums. Okay. The circular array means the end of the array is connected to the beginning of the array. This is formally defined as the next element of any element at index I in the nums array is defined as nums of I plus 1 modulo n. And similarly, the previous element of an element at index I is defined as nums of I minus 1 plus n modulo n. The subarray may only include each element of the nums array only once. Let's take a look at the example 1. So we are given the nums array with 4 elements. From this array we can create few subarrays. First we can create the sum of all the elements in the array. In that case we get 0, and if we include the first 2 we get minus 1. If we include the first 3 we get 2. If we include the second 3 we get minus 1, and if we include the last and the first 2 we get minus 3. But if we include only the element 3 in a subarray, then we get the maximum sum among all other subarrays sum. So that's why the expected output is 3 for this case. In the case of example 2, we are given a nums array with 3 elements, 5 minus 3 and 5. So in this case, if we create a subarray with the last element and the first element, then we get the sum 10, which is the largest among other subarrays sum in this array. That's why the expected output is 10. And in the case of example 3, all the elements in the nums array are negative. So in this case, if we create a subarray with only minus 2 in it, that is the largest sum. So that's why the output is minus 2. The constraints for this problem are n is the length of the array, where n is ranging from 1 to 30,000. And the individual elements value is ranging from minus 30,000 to positive 30,000. Let's look at the approach to solve this problem. We are given the nums array with 4 elements, 5 minus 12, 1, 5. And the expected output is 11 because the subarray formed by the elements at index 2, 3 and at index 0, because this is the circular array, right? So the sum of this subarray is 11. That is largest value among other subarrays sum. That's why the output is 11. Because the subarray can be formed by connecting the last element and the first element. So the subarray formed by these two elements may be greater than the other subarrays sum. So we need to keep track of the prefix and the suffix sum in the array. We need some additional space to handle the case where the subarray is formed by connecting the last element and the first element. Okay, but we can solve this problem using cadence algorithm with constant space. Basically, we need to treat the input array as the regular array instead of a circular array, and we need to compute 3 things: the minimum subarray sum in this array, and the maximum subarray sum in this array, and then the total sum of all the elements in the array. These 3 things we need to compute. Okay, for example, here it is 5 minus 12, 1, 5. So the total sum is minus 1, and the minimum sum is this single element subarray minus 12. The maximum sum is the sum of the subarray at index 2 and 3, which is 1 plus 5, 6. Okay, so basically we need to compute these 3 things. Once we compute, we cannot directly subtract the minimum sum from the total sum and then return that as the maximum subarray sum of this input, because let's take a look at this case. If you look at it, the total sum is minus 9 and minimum sum of this subarray is minus 9. Okay, but we need to return the maximum sum of the subarray in this array. In this case, we supposed to return -2, right? So that's the reason we are computing the maximum sum also in this array. Okay, so whenever the total sum and the minimum sum are same, that means all are negative. To handle that case, whenever the total sum and the minimum sum are same, we simply return the maximum sum computed. So in this case, we return -2. Okay, if they are not same, then we need to subtract the minimum sum from the total sum. But again, we cannot return that value as the maximum sum because there may be another subarray which is larger than the difference between these two sum, right? So that's why we have to return the maximum of the maximum sum computed in the array and the difference between the total sum minimum sum. So in this case, maximum of 6 comma minus 1 minus of minus 12. So max of 6 comma 11. So we return 11 as the output, the maximum sum subarray for this input. So that's what I have written here. So basically we calculate maximum subarray sum using cadence algorithm, and again we calculate the minimum subarray sum, and then we calculate the sum of all the elements in the input array. Once these three calculations are done, then we check whether the minimum subarray sum is not equal to the sum of all the elements in the input array. Okay, in that case we have to subtract the minimum sum from the total sum and return that value if it is greater than the maximum sum computed, otherwise return the maximum sum. I have already posted a video for the maximum subarray problem. Please take a look at it for more details. I also leave the link to this video in the description. Let's look at the flowchart. Input for this procedure is nums array, and first we define the current minimum, current maximum, and the minimum sum, maximum sum, and total sum variables. The current min and current max are initialized with 0, and the minimum sum and the maximum sum is initialized with the first element's value in the input array, and the total sum is initialized with 0 and the index is initialized with 0. Okay, then we enter this for loop to process the input array, and in each iteration we compute the current max by comparing the current element at index I and the sum of the current max plus the current element at index I. Whichever is greater, that will be assigned to current max. Then the current max is compared with the maximum sum. If the current max is greater than maximum sum, then the maximum sum will be updated. Okay. Similarly, the current min is calculated by finding the minimum among the current element and the sum of the current min and the current element. Whichever is lesser, that gets assigned to current minimum. Then the current minimum is checked against the minimum sum. If the current minimum is less than the minimum sum, then the minimum sum will be updated with the current min value. And then current element value is added to the total sum. Okay, we repeat this until we process all the elements in the input array. Once that is done, then we come out of the loop. We check whether the total sum is not equal to minimum sum. If that is the case, then we find the maximum of maximum sum and the difference between the total sum and the minimum sum. Whichever is greater, that gets assigned to maximum sum. The maximum sum value is returned as the output. Let's move on to coding. First I initialize the current min sum and the current max sum variables with value 0. And then initializing the minimum sum and the maximum sum variable with the value of the first element in the input array. And then initializing the total sum variable with value 0. Next I write the for loop to process all the elements in the input array. Each iteration I update the current min sum with the value that is minimum of current min sum plus the current element and the current element. Next I update the minimum sum variable with the lowest value among the current value of the minimum sum and the current min sum. Next I update the current max sum variable with the value that is larger among the current max sum plus the current element and the current element. Next I update the maximum sum variable with the value that is larger among the current min sum and the maximum sum. And then I add the current element to the total sum. After coming out of the loop, I check whether the minimum sum is not equal to the total sum computed. In that case, I update the maximum sum variable with the value that is larger among the maximum sum and the difference between the total sum and the minimum sum. Then I finally return the maximum sum. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. We are given the nums array with 4 elements 5, minus 12, 1 and 5. And in this array, the sum of this subarray starting at index 2 and ends at index 0 has the sum 11, which is greater than all other subarrays sum. That's why the output is 11. Okay. So first we initialize the current min sum and the current max sum to 0. Okay. And then the minimum sum and the maximum sum variables are initialized with the value of the first element in the input array, which is 5. Okay. And the total sum is initialized with 0 and the index is initialized with 0. Then we enter the for loop, and in iteration 0, the current min sum is 0, minimum sum is 5, current max sum is 0, maximum sum is 5, total sum is 0. Okay. Now we are updating the current minimum sum by including the element at index 0. Okay. First we assign the minimum value among the sum of the current minimum sum, which is 0 now, and the current elements value, which is 5. So 5 comma 5, that is the current minimum sum. So it is changed from 0 to 5. And then we compare that new current minimum sum with the minimum sum. Both are same, so there is no change in the minimum sum value. Similarly, we compute the current max sum by comparing the sum of the current max sum and the current element and the current element. Whichever is greater will get assigned to the current max sum. In this case, 0 plus 5 comma 5. So the current maximum value is changed from 0 to 5. And then we add the current elements value to the total sum. So the total sum becomes 5. Okay. And in the iteration 1, we pick up the element at index 1. Now we assign minimum of 5 minus 12 comma minus 12. So this is minus 7 comma minus 12. So the minus 12 is the smaller. So we assign minus 12 to current min sum. So it is changed from 5 to minus 12. And similarly, the current max sum, we find the maximum value among 5 minus 12 comma minus 12. So minus 7 is greater. So the current max sum is assigned with minus 7. Next, minus 12 is added to the total sum variable. So it's changed from 5 to minus 7. And in iteration 2, we pick up the element at index 2, which is 1. Okay. So now we are updating the current minimum sum. So the current minimum sum is minus 12 plus 1. It becomes minus 11 and this is 1. So minus 11 is smaller than 1. So the current min sum value is changed from minus 12 to minus 11. And then we update the minimum sum. In this case, the newly computed value is greater than the existing minimum sum value. So it is not changed. It remains minus 12. Next, we compute the current max sum. So in this case, minus 7 plus 1 minus 6 comma 1. So 1 is greater than minus 6. So the current max sum is updated with 1. But the maximum sum is still greater than the recently computed current max sum. So there is no change in the maximum sum. It remains 5. Next, 1 is added to the total sum. So it's changed from minus 7 to minus 6. Next, we pick up the element at index 3, which is 5. Okay. So now minus 11 plus 5 minus 6 comma 5. So minus 6 is smaller than 5. So the current min sum is changed from minus 11 to minus 6. Next, we find the minimum sum comma current min sum. So minimum sum is minus 12 comma minus 6. So minus 12 is smaller, so there is no change. It remains minus 12. Next, we compute the current max sum by comparing the current max sum plus the current value 5. So it's changed to 6. Okay. And we update the maximum sum by comparing the current value and the current max sum. And the maximum sum value is 5 and the current max sum computed is 6. So 6 is greater than 5. So the maximum sum is updated with 6. Next, the current element is added to the total sum. So the 5 is added to the total sum. So the total sum is changed from minus 6 to minus 1. Then we come out of this loop and then we check whether the minimum sum and the total sum are not equal. So in this case, the minimum sum is minus 12 and the total sum is minus 1. So in this case, we try to find the larger value among the maximum sum and the difference between the total sum minimum sum. So the maximum sum is 6 and the total sum is minus 1 minus of the minimum sum, which is minus 12. Okay. So we get 11. We get the maximum value among these two, which is 11. So the maximum sum value is 11 and this is returned as the output. That is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of n. Okay, because we need to process all the elements in the input array, we need to traverse all of them. So let's take a look at the case 1. Okay, so here we have 4 elements in the input array. So this for loop performs 4 iterations. In case 2, we have only 1 element. So this for loop performs 1 iteration. So if there are n elements, this for loop performs n iteration. That's why the time complexity is order of n. The space complexity is order of 1 because we are not using any additional space. We just use only few variables. Regardless of the input size, we use only 5 variables. That's why space complexity is order of 1. Thanks for watching this video. Have a great day.